I thought I had this circuit already solved in video format. Maybe I have, but look, what I've decided to do is just a small 5, maybe less than 10-minute segment to show how I would solve the total resistance for this circuit shown on the board. And because we're up to parallel circuits, we've done series circuits to death, we're up to parallel circuits. We first of all look at this, we identify that we have one glaring parallel circuit in front of us. And to solve that particular parallel circuit there, you know, we've learned 4 different ways that we can solve a parallel circuit. We can use the sum of the conductances, we can use product over sum, we can use R over N, in example where you've got multiple identical value resistors, or we can use simple Ohm's law with R equals V on I. So that's 4 different methods that we can use to solve parallel resistances. In this particular example here though, look, I'll probably just use sum of conductances because it's very easy to put into the calculator. So simple calculator, it'd be 680 x to the minus 1 plus 560 x to the minus 1 equals x to the minus 1 equals. And just putting that up graphically then, it's going to be 1 on 680 plus 1 on 560, and that'll be 1 on the whole lot. And that gives us 307 ohms of resistance to work with for that parallel network. The next part of the solution, I can see that I've got some resistors in series at this point. So I'll put a bit of a loop around those, and 330 plus 150, that's going to equal 480 ohms. And I know that I've got my 307 ohms there. That 307 ohms is in fact in series with these two, so I have to add the 307 to the 480, 307 to come up with 787 ohms at that point in the show. Now, the next parts of the circuit, where I think a couple of students in class said, oh, we can do something with these now, not quite right. We have to first of all work with this little critter here, 1K. And I reckon because we know now that the sum of all of these is this 787. That's why I've put a big loop around all of those. But we need to use a different colour now. And I hope green comes out okay. I never know. I've got a slightly different camera today and different colours sometimes come out slightly different. I hope the contrast is okay. We're going to take into account now this 787. It's in parallel with that 1K. So here's the 1K. And it's in parallel with all of what we worked out so far, which was 787, just to redraw it like that. And that's that large green circle that I've put around all of that. 1K in parallel with 787 ohms worked out to be 440.4 ohms. 440.4 ohms, and that's all of that green large circle. So what have we got left then? We've got 270 plus 440.4 plus 330, because now 3 things are in series together. Let's just redraw that then. There's our 270. Here's our 440.4, and here's our, down the bottom, 330. Ohm resistor. So we add all of those together and we come up with 1040 ohms. The task of this whole problem was to find the total resistance and then find the total current. So IT, I equals V on R, so the supply voltage is 15 volts divided by 1040 ohms And of course, that allows me to draw my main circuit current on there at 14.42 milliamps. And then in the first part of our lab, we're just going to construct this circuit, and we're going to then prove that all of our coloured looping here works. And the main thing, I guess, to say about this circuit and how I did that solution was the battery is on the far left-hand side of the circuit, and I started at the right-hand side of the circuit, and I worked my way back across towards the battery. So in fact, I could have said, okay, they're in series, let's do those first. Then the next thing along, they're in parallel. Then all of that is in parallel with that critter. And then all of that lumped together, 440.4 is in series with him. And that gave us our 1040. And that allowed me then to work out 14.42 milliamps. This has been Greg Moore for TAFE New South Wales as part of UEENEEE104A. Parallel circuits. Thank you.